Hello friends, welcome to the video. Today in this particular video, we're going to be discussing a different problem called the validate subsequence problem. I hope you can see my screen and the problem we have is on the screen. We're going to go over it once, read the problem, understand the problem, and then move forward, look into the complexity of the problem and try to write a program to solve that problem. So validate subsequence, it says given two non-empty integers array of integers, write a function that determines whether the second array is a subsequence of the first one. A subsequence of an array is a set of numbers that aren't necessarily adjacent in the array, but that are in the same order as they appear in the array. For instance, the number 1, 3, 4 form a subsequence of the array 1, 2, 3, 4, and so do the numbers 2, 4. Note that a single number in an array and the array itself are both valid subsequence of the array. So let's jump into the whiteboard and see what this problem is trying to understand this problem. First, we have a sample input as given to us, so to play with. So here's our whiteboard. So the array that we have, the example that they have given in the question is, they're saying 134, for instance, the number 134 forms a subsequence of the array. So the first array that we have is 1, 2, 3, 4, right? Now they say in the first example, the array 134, which is our input, right? Let's just say, or the subsequence, right? 1, comma 3, comma 4. Right? This is the input array. Now, is this a subsequence? They say that this is a subsequence because you see one exists. After one, there's three, and after that, there's four. And their order in the subsequence is same as their order in the input or the array that they have given, input array, right? Which is basically just an array. So this is a subsequence because the numbers appear in the array in the same sequence. Let's look at the other example that they have given. The another input that they have given is 2, comma 4. Right. Now let's see. Our array is 1, 2, 3, 4. So number 2, yes, number 2 is present. Number 4 is present, and they are present in the same order. That's why this is a valid subsequence. And the question says, one more point to pay attention to is note that a single number in an array and the array itself are both valid subsequences of the array. So a single number, let's just say you have array of 1 and you're checking subsequence 1, then they are both valid subsequences. And if there are two arrays, let's just say 1, 1, 2, 3, 4, right? And there's another one, 1, 2, 3, 4, almost identical arrays. They are also subsequence of each other. Okay, let's open another. Now, the input that's given to us, let's look at the input, the other example that's given to us. So inputs are 5, 1, 22, 25, 6, -1, 8, and 10. Right? And subsequence that we need to check for is what, 1, 6, -1, -1, and 10. Right? So is this is this a valid subsequence? How do we check? Let's see. So let me write it here. 1, 6, -1, and 10, right? Does our array have 1? Yes, it has 1. Does it have 6? Yes, it has 6. Does it have -1? Yes, it has -1. Does it have 10? Yes. And they are all in the same order. The order in which the order in subsequence is the same as the order in the array. So they're in the same order and they're all present. So, you know, it's a valid subsequence. All right. Let's look at the complexity of this, how we can solve this and what complexity analysis, we do, what kind of complexity we would see. So, okay, okay. So let's solve this for complexity, right? So the complexity of this program would be if we take, say, 1, 2, 3, 4, this array, right? And the elements in this one are, let's just say it's a subsequence. This is the input array, let's just say. Okay, array is equal to this. And the subsequence we are trying to validate is 1, 3, 4. So one thing, the first thing, the simplest way to solve this problem would be pick up subsequence 1 and see if 1 is present in the array. Okay. So yes, 1 is present. Then you pick up 3 and right away from the start, right? Compare 3 with 1, compare 3 with 2, compare 3 with 3 and see if 3 is present. Yeah, 3 matches this location. Okay, so 3 is present as well. Then you check if 3 is at a higher index than 1. So this index is 0, this is 1, 2, and 3. Is 3 at a higher index? Yes. So that means the sequence is also good, right? Ordering is good. Now let's look for 4. Compare 4 with 1. Does it match? No. 4 with 2? No. 4 with 3? No. 4 with 4? Yes. Now, and then check the index. Is the index greater than the index where third match was found, the second match was found for number 3? Yeah, that index was 2 and this index is 3. So the index is bigger than that index. So that means the ordering is maintained. The ordering is good. Now to compare each element, right? Our complexity would be O of n. And for this array also O of n, because we are comparing each element, right? Every time we pick up one element, compare with each element in the array, then pick up another element, in the subsequence and compare with each element in the array. So our whole complexity in this case becomes O of n square. Can we improve this program? Can we improve this complexity? Can we do better? Let's see, right? Now, the array 1, 2, 3, 4, right? And the subsequence is what? 1, 3, 4. So we first pick up number 1 from the subsequence. We see if this number is present in the array. Yes. So now, to improve the complexity, when we pick up the second number, we know that third should be present after 1. So what we do is, we don't compare it with 1. We compare it with any value that's present after 1, right? So we compare 3 with 2. Okay, does not match. Then we compare 3 with this one. It does match. So now the index here was 0, 1, 2. Now the next comparison when we come to number 4, right? Number 4, we only compare with anything beyond number 3 because we know the last match was found at index 2. So the next number should be present after index 2, not before 2. So we pick up 4, we try to compare it with number present after 4, and it's a direct match. So if you see for this particular array, right? We only did O of n iterations, right? So we only did O of one n iteration. So basically, we only went through the array once, right? For this, since the number of elements in this one is different, we're going to call it O of m. So for O of m, right, and O of m, and in both cases, we are only iterating through the array once. If you would have paid attention, it's not like I'm picking up every value and then I'm going four times, iterate over each value in the array, or so my complexity here becomes, since we are both, iterating over both the arrays or running over both the arrays and visiting every element only once, our complexity here becomes O of n plus m. And this is lesser than, or you can say better than, O of n square, right? So this is the complexity that we wish to achieve. You can also say that O of n plus m is equal to or similar to O of n. Okay. So your best case is O of n. And since we're not going to be using any extra space in this program, our space complexity would be O of 1 because we are not using any extra space, right? Let's now dive into the program. So let's see what we can do. I'm gonna create basically, I'm gonna start with a public static void main. Main string array public, forgive me, public boolean as valid subsequence, and we have two lists here, integer array. So let's think about integer subsequence, right? And we return true initially. So from here, I'm gonna call my program, create an object of a program class, right? And then dot response subsequence. So I have to pass two lists here, right? I'm gonna create two lists. Okay, array, so new array list, which is the list of elements, right? And another list is going to be a list of integer sequence is equal to new is the elements, right? And I'm gonna just copy a bunch of elements. So I'm gonna pass the first array and then I'm gonna pass sequence to the program, right? I'm gonna put this inside a sysout so we can see the output on the console. Let's write the program. So what we're gonna do is we're gonna iterate over the sequence first. Okay, I is equal to 0, I is less than mm, sequence dot size I plus plus, right? So now once so for the second one, I'm gonna do int of I, no, j is equal to 0, j is less than, so first one the sequence, the second is gonna be array dot size, right? And j plus plus. So I'm gonna and also create a boolean basically where I say match found is equal to, initially the match is not found, and as soon as we found a match, so I'm gonna take a sequence, right? From the sequence, I'm gonna take the first element, and initially I'm gonna say, okay, for this element, the match isn't found, and as soon as we found a match, we're gonna say, turn the match found variable to boolean to true. So now index is equal to 0. I'm gonna make j is equal to index. So right now, if you see the starting position for even j in the array is gonna be 0. But what I'm gonna do is once you know my second element, first element I found, right? Now I know if first element was found at position 2, the second element should be after position 2. It's not gonna be before position 2, right? So I'm going to use that index and make sure that, I do not revisit any of the elements, right? So let's just do this if here, if now my array dot get, right? Now first is my sequence, right? So sequence dot get index I. So the first element from the sequence equals array element of j, array dot get index j. If they are both equal, then set my index to j plus 1, right? Because in the index, if this variable was found at second position, the next sequence variable from the sequence or element, this be sequence is going to be at a position that's greater than the position of this element, right? So that's why I basically increase the index to follow from that particular number onwards. Instead of, if I just do day j, what's going to happen is if the first match was found at index 2, then for the second match, it's going to start from index 2. I want it to start from index number 3, from location 3. I don't want it to start from number 2. Because if the numbers are same, there could be a match, right? So I want to avoid that position because a match was already found at that position. So I want it to go from the position next to it. That's why I do j plus 1. And what I'm gonna do is if they're both equal, right, then index is increased, and I will set match found. Yeah, match found equals true. I found a match for this one, and break, right? And at the end of this for loop, right, this inner for loop, I'm gonna check if in case there was no match found, in case there happens to be, it happens that there was no match found, then you just return false. It's not a valid subsequence, right? And end the program. If always, there's always a match found, then you go return true. Now let's run the program. True. We might want to check it with one more set of data. So make sure this is good. Okay. So that's true too. I want to see if there's, let me check for one that's not a valid subsequence. So the subsequence has four ones and a two. This wouldn't be a valid subsequence. And my answer is false. So that means this program is good. It works fine. That's it for this video. Thank you so much for watching, and we'll be back with another program, another complexity problem, and we'll solve it. We'll look into that, we'll dive deep, and we'll try to understand. Thank you so much for your time. Bye-bye.